In this video, we will discuss how to calculate crystallinity index from XRD data using Origin. We define the crystallinity index as a quantitative indicator of crystallinity. The crystallinity index can be defined is the area of all the crystalline peaks divided by the area of all the crystalline as well as amorphous peaks. So in terms of XRD data, I can define it as area of all the peaks, which we call the crystalline peaks, divided by the total area, which is consisting of the amorphous portion as well as the crystalline peaks. Now, for example, I consider an ideal versus a synthesized crystal. For ideal crystal, the width will be negligible and we will have sharp peaks at different locations corresponding to the planes of the material, while in a synthesized crystal, this one is having a certain width and showing different planes here, but this portion is amorphous and the profile shows that the crystallinity is more here compared to this profile, which is having more noise and the crystalline peaks here. We will calculate, for example, the crystallinity index for this will be 100%. Here it will be less than 100 and this one will be less than this one, which is over here. So as the amorphous nature increases, the crystallinity index will drop. And here we are having the XRD of amorphous glass. We know that in typical glasses, this one is a very broad peak, which is also very noisy, and this is due to the main matrix of the glass, and rest are all oscillations are noise. Such a plot shows amorphous material, and when we will find the crystallinity index for this, it will be around 20 to 30. So inside a glass, we are having a crystalline structure, but it is superimposed by the amorphous or the modifiers inside the glass. Now to find the crystallinity index from XRD data, let me start with an origin file. And this is the XRD data. We are having a synthesized crystal XRD data and amorphous glass here. Now let's plot this data, and here it is. Now I can see here that baseline correction is required here. So I go to peaks and baseline and then the peak analyzer, and then I will open the dialog. And here I will go to subtract baseline. Now here I will have to be careful not to select the constant but the user defined, because the constant profile will not do the job. So now it will be perfect, and I go next, next, and I finish this. So it has generated the baseline here, and let me plot the two in order to see the difference between the two profiles. And here it is. We can now clearly see that the baseline subtraction is aligned or plot, and this is the difference between the two. So from now on we will go on with the baseline subtracted data for finding out the crystallinity index. Now let's plot this data. Let me increase the size of it for the visibility. And here is our XRD data, and now we will have to find the area of all these crystalline peaks. So I go to the peaks and baseline peak analyzer, and I will open the dialog. And now I will select the integrate peaks. As the baseline mode comes in, now I will select the constant, because now I know that my plot is aligned, and I will note this value because I will have to come to this value again. So this value is supposed to be constant, otherwise the area value will be different for each calculation. I can see here that this one is perfect now because it is almost touching our plot. And I click next, next. And here the number of peaks are 0 and enable auto find is selected. So I will click find, and it has found 3 peaks here and here, but this peak has not been found, so I will have to include this peak as well. Unclick the auto find and add this peak here. Click done, and now we are having 4 peaks. And I go to next, and now it has indicated the area around the peak. So the area is supposed to be symmetric, so I will have to adjust on preview. And now I am able to just reduce or increase it or make it symmetric around the peak. So it is not the area of this region of interest, but it is actually the area of the peak, but it is supposed to be symmetric. And now I click finish. So it has generated the data here, and these are the 4 peaks and their respective area. So I will have to copy all this and paste it into the Excel template, which I will upload with this video, so it will be available to you. And I paste the 4 peaks area here. And now our next job is to find the total area of the XRD plot, which is containing both the crystalline and amorphous peaks. Amorphous peaks are actually the noise in our plot. So go back to the data and plot this data again. Now select this one, go to analysis and do the same practice again. Again we will go to the integrate peaks, and here the baseline value, and we will have to check that it is the same value as we did earlier. So it is the same, and I can go now next, another next, and now I will have to find the peaks, and as usual it will find those 3 peaks. And now I will have to consider only one peak here or the whole data. So I will have to drag the selection or the region of interest and here it is. So I selected one peak here, and now I will extend this one to the ends of the plot. And similarly this one ends as well. And this will give me the total area of the crystalline as well as amorphous peaks. And finish. So it would have calculated the total area, and here it is, which is 72.435. Copy this and go to the Excel template and paste it here. And here is our crystallinity index. So our material is more than 80% crystalline in nature. Now the second calculation we can do another way very easily. Select the data and plot it. Now go to gadget instead of analysis, and under the gadget we go to integrate, and here we are having the options. Now I will calculate the area here, and I will have to check this one in order to keep the selection. Now go to the baseline, and here I will have to select the value, and this value is constant. And now I go here and I select this value, and I paste this one for the consistency with the other area. And now the baseline I have selected is constant, and now I select OK. And here I will just drag it to the two ends. And here is the total area, which is 72.45. While in the previous case we calculated this 72.44. And now I go to the amorphous glass, and here I plot this data. And now I will have to find this peak and then the total area. It is to be kept in mind that this peak is not having its end very clearly, so we will have to approximately select the size of this peak. So go to Peaks and Baseline, Peak Analyzer, and then open the dialog. And here we will have to go on to integrate the peaks. We will not create a baseline because this one seems right, as it is an amorphous material. So this is the baseline, and I can check here that it is at y equal 454, and we can see here that the baseline is right. We will have to remember this value, which we will have to use for the rest of the calculations as the constant baseline here. So I go next, and now here I will have to find the peaks. If I click the find the peaks, then it will select enormous number of peaks here, which is 706, and this one is not required. So I will clear all these peaks, and I will just add this one peak here. So double click here, and this one peak will be selected, and it's done. So go next, and now we will have to select the region of interest. Click on adjust on preview, so we will be able to do it here. Just approximating the size of it. This is not very crucial. And now I go and finish this, and I will get the area of this peak. And here it is. This is almost 3000. So again I copy this and move it to the template. Now instead of 4 peaks I am having only 1 peak, and I just paste that area here. And now I will find the total area. So to find the total area, I will have to go back to the data and repeat the same practice here. First, I will plot the data, and then to the gadget I will go instead of the analysis, because this one is comparatively quick. And here I will select that value which we did earlier. It is 454. And now here I will take this option and I click OK. And now I will have to drag it to both the ends. And here it is, and the total area comes out to be 8382. So I will copy this data and go to the Excel template, and here I will paste in the total area. And here our material is more than 30% crystalline, so it is under the category of amorphous. Thank you for watching the video.